This is the Singularity University GSP 2009 class.
Well, it's great to be here.
Ray, what are your thoughts on the Singularity now, in terms of timing?
Yeah, well, I mean, I have a new book. The Singularity is Nearer. It's completely written. Um, I've shared it with a few people. Uh, and it's very much consistent with the views I expressed in The Singularity is Near, which is 17 years earlier. Um, but it has new perspectives. And when that book came out, we didn't have smartphones. We had very little of what we now take for granted. Um, and the kinds of views that I've expressed for the singularity are much more acceptable. I mean, people have never heard of that kind of thing before. Um, so I discuss the singularity with the new perspectives of how we currently understand technology. Um, and it's actually an optimistic book. I mean, people are very pessimistic about the future because that's all we hear on the news. And what we hear in the news is true. There is bad news, but the good news is actually better. And I've got like 50 charts that show different indications of human well being. And every year they get better. And that's really not reported. Uh, Peter Diamandis has talked about this as well.
What kind of things have surprised you about how technology has developed or how it's affected our society, Ray?
It really hasn't surprised me because it's really in line with what I've been expecting. Um, I mean, there was, for example, a poll of 24,000 people in 23 countries asking whether poverty's gotten better or worse over the last 20 years. Almost everybody said it's gotten worse. The reality is it's fallen by 50%. And there's one poll after another that shows that people's views are quite negative, whereas the reality is quite positive. Not to say there isn't bad news. We see that all the time on news programs. So that's one issue that I talk about. Um, but we're actually pretty close. I mean, I think we'll actually pass the Turing test by 2029. That's what I actually started saying in 1999 and in my book at that time. The singularity is near. It said the same thing in 2005. But we're actually getting pretty close to that. But we actually have things that come pretty close. In many ways, they're better than humans. In some ways, they're not quite there. But I think we have an understanding of how to solve those problems. So I think we'll actually probably beat 2029. And in the 2030s, we'll actually begin to merge with that. It won't just be us versus computers. We'll actually put them really inside our minds. We'll be able to connect to the cloud. I mean, consider your cell phone. It wouldn't be very smart if it didn't connect to the cloud. Most of its intelligence is constantly getting from the cloud. And we'll do the same thing with our brains. We'll be able to think that much more deeply by basically amplifying our ability to do intelligent type processing directly with the cloud. So that's coming in the 2030s. And so our thinking then will be a hybrid of our natural thinking and the thinking in the cloud. But the cloud will amplify. Our natural thinking doesn't advance. So when you get to 2045, most of our thinking will be in the cloud. So that's the singularity.
Has your thoughts on life extension changed, or do you see?
No, in fact, we're now applying AI to life extension. We're actually simulating biology. And so we can actually do tests with a simulated biology. So the Moderna vaccine they actually tested several billion different mRNA sequences and found ones that could create a vaccine. And they did that in 3 days. And that was the vaccine. We then spent 10 months testing it on humans, but it never changed. It remained the same. And it's the same today. And we're going to be able to do that. Ultimately, we won't need to test on humans. We'll be able to test on 1 million simulated humans, which will be much better than testing on a few hundred real humans. And we can do that in a few days. So we'll be able to actually simulate every possible sort of antidote to any problem. And we'll go through every single problem and come up with solutions very quickly and test them very quickly. And that's going to be something we'll see by the end of this decade. So we're going to be able to go through very, very quickly all the different problems that medicine has. The way that we've been doing it, testing with humans, takes years. Then you come up with another idea, and that takes years more. We could actually test them all, every single possible solution, very quickly, and that's coming now. And we saw some of that with the Moderna vaccine.
But medicine doesn't seem to adapt to that, Ray. I mean, as you say, the vaccine was developed before the lockdowns even began. It wasn't deployed until probably 2 million people would be alive if we had the knowledge that we could deploy that vaccine immediately, which is quite a large number. And medicine doesn't change its practices and styles nearly as quickly as technology changes.
Right. Well, some people were skeptical because it was developed so quickly, but I think we're going to have to get over that. But it is good that we had the vaccine. Otherwise, a lot more people would have died. And I'm not saying we're there yet, but we are beginning to simulate biology. And ultimately, we'll find solutions to all the problems we have in medicine using simulated biology. So we've just begun. And I think we'll see that being very prominent by the end of this decade. But people have to want to live forever. I mean, if they avoid solutions to problems, then they won't take advantage of these advances. So we'll have the opportunity, but that doesn't mean everyone will do it. We have a very large anti-vax regimen, possibly because it was created so quickly.
What do you feel most optimistic about now, Ray, or most hopeful about?
Well, I mean, AI is going faster and faster. I mean, I've been in this field, say I got involved when I was 12, so I've been in it for 60 years. I got involved only 6 years after AI got its name in the 1954 conference at Dartmouth. And things were very, very slow. It would take many years before anything was adopted. When I got to Google, which was about 10 years ago, things were going faster. It would take maybe a year or two to develop something that would be adopted. Now things are happening like every month. So the acceleration of technology in general, and particularly in AI, we can definitely see. And things that are a real serious problem, we seem to overcome very quickly. So we're going to see tremendous progress by the end of this decade.
Hi, Ray. Great to see you, or hear you at least, and excited to be with everybody. From AI, I'm curious, now you're in the middle of working on large language models you've always been around kind of all different angles of AI. So what do you think is going to be the most promising approaches of AI to really get us to the full potential AGI, past Turing tests, super intelligent machines? Do you think, for example, it's continued progression of sort of large scale language model type of things? Or do you see a fusion of sort of neural and more traditional logic-based and symbolic-based approaches?
Well, first of all, we need to continue to increase the amount of computation. We're using an amount of computation now that is sort of beyond what we can actually provide everybody, but we can at least see what's going to happen. And as we increase the computation, these systems do a lot better, and they overcome problems they had before. There are some algorithmic improvements we need. I mentioned inference before. It doesn't do inference very well. However, we have some ideas that we believe will fix that, but it also requires more computation. The human brain still has a lot more computation than even the best language models. I mean, right now we're like 500 billion parameters, and it's still not what the human brain can do. So if the human brain thinks about something very carefully, it can go beyond what these machines can do. However, we're advancing them very quickly. Like every year, we're multiplying by 5 or 10 the amount of computation. So that's one key thing that's required. And we do need some changes in algorithms. I think we have some ideas of what to do. I mean, we're exactly where I would expect to be in 2022 to meet the Turing test by 2029, which is what I've been saying since 1999. And we also have to collect data. That's a very important issue. I mentioned simulated biology. We have to actually collect the data that would allow us to simulate biology for different kinds of problems. We've done that in some areas, but actually collecting all that data is extremely important, and being able to organize it and so on. So that's happening, but that's another thing that's required.
Ray, good to see you again. I have a quick question. I was talking to Jeffrey Hinton, and he said that we really need a next level breakthrough after deep learning to progress AI to the next level. And I'm wondering if you agree with that and if you've seen anything on the horizon that would fit that criteria.
Yeah, well, he's always been more conservative than I have. I think we have the correct methods. Neural nets, if we just amplify them with new technology, it wouldn't quite get us there. So we do need some additional ideas, but we can actually change neural nets to do things like inference. And there was a recent paper on jokes developed by a new massive model. They're actually getting there. So I think we're on the right direction. I don't think we needed a massive new breakthrough. I think the kind of neural nets that he's advanced are good enough with some of the additional changes that are now being experimented with. So yes, I do think we need some additional things, but they're being worked on. So it's maybe just a difference of emphasis. But I think we're on the right path.
What do you think the pandemic shifted the priority of the future of medicine, as well as other fields that you'd like to share with us?
Well, I mean, we did create one of the methods that we've been fighting COVID using simulated biology, as I said. And I think the fact that it happened so quickly is actually has partly fueled the anti-vax movement. So I think we need to actually develop this idea. I mean, we've had vaccinations actually for over a century, but they generally take a while to develop. So the fact that we were able to do it so quickly by simulating biology is a surprise to people. And it's actually going to go faster. The U.S. government has a plan to actually create new vaccines within a few months, 2 or 3 months. And it's going to go even faster than that. Because actually the Moderna vaccine, was, as I say, was actually done in 3 days. They started it, they simulated every single mRNA vaccine and tested it in 3 days. Now people then wanted to test it on humans. I think eventually we will actually, it'll be much better to test it on 1 million simulated humans than 100 real humans. So we will get there, but anyway, this was actually the very first time that we actually used simulated biology to come up with something. And I think simulated biology will work for every single medical problem. And actually, one of the key ideas is to collect the data. That's going to be very key, because you need to collect data for every single problem. If you have all the data, then you can run it and figure out an answer very quickly. So I'm very excited about that. And that's the type of change we needed to really break through lots of medical problems that have been an issue for many years, decades.
So what would you say is the most surprising thing to you over the last decade? You said most things were not surprising you, but surely something has surprised you.
Well, I mean, I'm not surprised, but I'm quite amazed at large models. Many of you have actually talked to a large model. It's become actually already a major thing in academia. If you're to write about something, you can just ask a large model. What do you think of this philosophical problem? If you had a trolley, if you substituted something in the trolley problem, how would that be? And it will actually give you an answer, and a very well thought through answer. And the new models that are coming out now that are 5 times the size, 500 billion parameters rather than 100,000, 100 billion, they even give you better answers.
Have you ever asked a model to predict the future of technology and it said something to you where it said, "Oh, I didn't think of that"? That's a very trick question for you, Ray.
Well, I'm not actually predicting the future. I'm just giving the capabilities that we'll have to affect it.
No, I'm specifically meaning your task in life has been to try and forecast futures of technology. And so when a model impresses you because it does something in your task of life that you didn't think of, that would be a particular bar that I'm asking about.
Yeah. Well, I mean, these large models don't always give you the same answer. In fact, you can ask the same question 100 times and get 100 different answers, and not all of which you'll agree with. But it's like talking to a person. And this is actually now affecting academia, because if somebody's asked to write about something, you can have the large model write about it. And you can ask it a question. If you don't really like that answer, just ask it again. Finally, you find something you like, you can submit it. There's no way that anybody could find that you've done that, because if they ask the same question that you were asked, they'll get a different answer. So unless they can tell that it's not your writing style, but since everyone will have these large models anyway, it's very hard to say what your writing style is. So it's really a writing tool. So I wouldn't say that surprised me, but I think it's really quite delightful to have this kind of intelligence come from a model. This was never capable before. And they're still not at human levels. So we're going to see even more surprises from these over the next, several years.
Hi, Ray. It's Bill Hunt. Good to see you. Good to see everybody
Yeah.
here. So you and Barney had touched on this earlier about the nature of models in large models, especially around like transformer-like models and kind of these universal models. And it seems, first of all, so first question, is it really all about just computation? Like the future of innovation is really all about like how many nodes can you throw at it? And then ultimately that becomes a question of how many dollars you can throw at it. And then my second question is, so
Well,
today,
well, let me ask one. Let me
please,
respond to one at a time.
please.
I mean, we are going beyond what's affordable. So some of the largest models we really can't allow like 1 billion people to use. But we're able to see what they're capable of doing. So it actually gives us a direction. But it's not just the amount of computation. I mean, the amount of data is important. Some of the first models were trained basically on the web. Not everything on the web is accurate. And so it put out a lot of things that were basically at the level of the web, which was not totally accurate. So we're actually finding ways to train on information that's more accurate, more reliable. And in particular, if you're trying to solve a particular problem, like what mRNA sequences can you deploy to create a vaccine? That's a very specific type of data. You got to collect that type of information. And so we're doing that. And so collecting data, as I said before, is very, very important. And then neural nets by themselves are not adequate. They don't do inference correctly. But that's kind of something that's not fully solved. I believe it will get solved, but that's a question that's not fully solved, and it has to do with inference, understanding what the statements are saying and what the implications are, being able to do multi-step reasoning. That's a key issue. So that's what's being worked on now. So there's algorithmic issues, there's data issues, there's the amount of computation. The amount of computation is very important, though. Unless you have a certain amount of computation, you can't really simulate human intelligence. And even with like a 500 billion parameter model, we're still not at what human beings can deploy when we deploy it on a specific issue.
Yeah, thank you. So my follow-on question is, so across the nature of lots of computation, there's lots of money. Across lots of data, there's lots of money. Today, we're in a world where a couple people with a laptop or a couple laptops in a garage can, build some tremendous innovation. What do you think about the societal impacts if all of the innovation is really around these systems that are just enormously expensive? and how that changes that economic disparity and situation.
Well, I mean, there's still a lot you can do with a few laptops that you couldn't do in previous times, and lots of people are creating very successful companies without having to spend millions or hundreds of millions of dollars on these types of innovations. And a few people are doing the training. It's really the training that requires a lot of money, and to actually run these is not as nearly as expensive. And so you can do that yourself if you can use a model that's trained by somebody else. So a lot of people are doing that. I mean, Google and other companies, Microsoft and so on, are making these models available, and then you can use them. And it's not, no one company is controlling it, because there are multiple companies that are making this available. So yes, there are some things that require money, but then everybody can share that training, and that's what we're seeing.
Thank you so much. And my last question, what do you think about the future of democracy? If technology is going to help somehow fix a little bit the problems that democracy is
Well, I
having?
have a chart on democracy over the centuries, and but it's gone way up. And yes, we see some players in the world that are not democratic, but the number of democracies and the number of people controlled by democracies has gone way up. And if you go back, even I mean, when the United States was formed, that was really the first democracy. And if you look back at that, it wasn't perfect democracy. We had slavery and so on. And if you look at it now, different countries have different levels of democracies. There's problems with it, but the amount of democracy in the world has gone way up. And I do believe that's part of the good news of people. And we see actually democracies getting together today to fight people who are trying to oppose that. So yes, we've made tremendous progress. And lots of countries that are democratic today were not democratic, even a couple of decades ago.
Nice. Thank you so much. I hope to see you in Tokyo in the future. Thank you.
Yeah.
Hi, Ray. Greetings from New Zealand, and also great to see everybody here. I just have one simple question, I guess. I've always been fascinated and interested in the future of humanity in space. So, do you have any predictions on when you think humanity will be a multiplanetary species?
I'm sorry, I missed a few words there.
Oh, sorry. Yeah, I guess my simple question is, do you have any predictions on when you think humanity will be a multiplanetary species?
Yeah, I mean, Peter's very concerned about this. I've been more concerned about amplifying the intelligence of life here on Earth. But I do, and I think it's going to be a future era beyond the singularity when we actually have kind of exhausted the ability of here on Earth to create more intelligence. But I do think at some point our ability to actually create more computation will come to an end because we really won't have more material to do that with. I talk about computronium, which is was actually pioneered by Eric Drexler, as to how much computation can you create if you were to actually organize all the atoms in an optimal way. And it's pretty fantastic. You could basically match all of the intelligence of all humanity in sort of one liter of computronium. And we'll get to a point where we've used up all the materials on Earth to create computronium. Then we'll have to move to another planet. And that's probably at least a century away. So that might seem very long. On the other hand, this world has been around for billions of years, so it's not that long. But at that point, it really will become imperative that we explore other planets. We won't want to send delicate creatures like humans. We'll want to send something that's very highly intelligent, and that it will then organize the materials on other planets to become computronium, and that will be something we'll do for centuries after. And then a key issue is whether or not we can go beyond the speed of light. Because if we're really restricted by the speed of light, this will take a very long time to get into places. If there's some way of going beyond the speed of light, then it will happen faster. So creating something on Mars, I think that's interesting. I don't think that'll affect humanity very much. I think it'll be our ability to extend computation beyond Earth, and that's really something that's way beyond the singularity.
Thanks so much.
What are some of everybody else? What are you doing now that we're a decade from having been together?
Great to see all you friends, and hear what everybody else is up to. I've been doing some fun things lately, and some people know, but others don't. A few years ago, with a few friends, we started essentially a venture studio around a set of world-changing technologies, a bunch of areas. You could say we just didn't want to pick one because they were all really big. So create a structure where we could create, some of these companies. Another organizing theme for us was preservation of essentially freedom and Western way of life, recognizing that we have this actually, giant arms race between great powers, and the future of our freedom to do what we'd love to do and be creative and flourish and prosper may have an actual risk to apply some of our energy towards essentially defense and intelligence as sort of a first market, which sorely needs it. That was around 3 years ago we started doing this, and I think just as COVID helped the world see the importance of biotech, I think the current situation in Ukraine and the world is helping us see that we really do need technology. Sort of makes a difference. These things, what's at stake, kind of really matters and is consequential. So working on that, a few areas, and we have some stuff that's kind of on the back burner in quantum computing, and also in post-quantum resistant encryption. The most active things we have right now are a data security company that is trying to unify all the problems around data security in one platform and framework. So how can you make sure that your data is not just confidential, as people are often worried about in security and encryption, but also resilient against all kinds of problems that may attack it, really indestructible, and also how can you really preserve the integrity of your data in the presence of all kinds of accidental or deliberate attacks. Most people, the US government can't really trust the data that we have now. It's very worrying and alarming. And if you were a large bank and electromagnetic pulse shut down your servers for a while and you came back up, there may be billions of dollars reallocated and no one would be able to say what it should have been. So these are some real challenges, and they all actually interact, and we're trying to solve them in a holistic way. That company right now is called Virtual Security. It's about to be renamed, but you can look a little bit about that on the website. Virtual Systems, virtualsystems.com. The other one, which is you could hear from some of my questions and closest for my background, is we're an AI company called GraphStacks.ai. That's GraphStax.ai. And we're really trying to address the broad future of AI. And the vision is that, from the technical vision, is that the future of AI is really coming from a deep integration and convergence of the neuro or statistical approach to AI with the logical or knowledge and model-based approaches. So, the pendulum has swung back and forth over the years, and there's been a huge amount of excitement around deep learning and all neural approaches, and I love it, and it's so exciting to see what is emerging from these things. On the other hand, it's hard to argue that these things are really able to use structural models and do anything like we can really do in science and engineered systems. So thinking about the full potential of AI, I think it's really a combination of those. And while we see the combination already showing up in things like self-driving cars, where the neural net might handle the perception and the symbolic inference system may handle the planning across the roads, that I would call as a shallow integration or a weak integration of the two. What we're striving for is actually an extremely deep integration at the foundational levels. So a system that basically has high order logic and theorem proving and inference kind of capabilities exactly at the same deep levels as it has sort of large scale neuro and symbolic, sort of neural and statistical inference and reasoning capabilities. So if you're doing logical inference and you're reasoning about symbols, those symbols may actually be grounded in embeddings. The embeddings can be learned, and based on the feedback, your embeddings of the symbols you're using change, and that can back propagate up through your logic and inference system changing. So we've been building our own from scratch programming language down to the metal, based on all kinds of modern developments that didn't exist when a lot of the symbolic AI systems were being developed, and with a specific eye on how we're actually unifying and joining these. And so we're making good progress on that, and it's very exciting. We'll be happy to talk with people about that. And we've also been applying it to problems in graph-based machine learning. And one of the key areas we started with was biology. So predicting what drugs will be toxic or not, or other kinds of effects of drugs and proteins and molecules. And through a combination of our approaches, we're at an exciting point where we're getting, at least on some of the key benchmarks, the best performance in the world. So we're yielding some really exciting results right now. And on the government as customer number one front, we've recently been awarded a contract. It's an IDIQ, which is a contracting vehicle, really, but it's good for up to $1 billion without having to be renegotiated. So it's kind of an exciting milestone. We still have to go and harvest all that, but we're in with very key customers and conversations in the government, and really working on things that are active and important for the future. So that is a little summary of what we're up to. Really excited about that, and happy to share it with and dive in with anybody else in our community who's interested.
I think Catherine's next.
Any
Catherine,
questions?
you
Otherwise,
want
I
an
can
update?
next. Yeah.
Hey, everybody. Good to see you in week, 668 of GSP09. And Yeah, these days, or this decade, I think my biggest focus would be how can we help get the Sustainable Development Goals done on time? We now have less than 9 years till the December 2030 deadline, and of course, for all the problems that the SDGs have, uh, if one is done late, that means that the people who are harmed by the undone, unfinished SDG were harmed by an act of procrastination, and we and the rest of the world deserve better than that. And that is part of why my big focus for the past 2 or 3 years has been talks and writing about the subject, the failure modes of smart people and the failure modes of experts. Because as we saw with COVID, in many times we've already got all the technologies and science that we need. We're running into the limits of human psychology. In many cases, that's the ways in which smart people and experts themselves get in the way of getting things done. And one of the beautiful lessons of GSP and SU was seeing what happens when you create an environment where you're bringing together a group of experts and smart people and giving them the attitudes and the mindsets and the experiences that get around these failure modes. So that's been my big focus, and it is just amazing to be able to see all of you, and to be able to have met you all those years ago, and then being able to see your journey since then has just really been an incredible honor. So thanks very much.
Thank you, Catherine. Let's see. I see Salim's hand up.
Hey there, great to see all of you. I was going to be giving an update, but I think I'll just keep it short here. I'm wearing my GSP9 t-shirt. You guys were the founding. I remember back when we did the summer, every day during GSP9, we had no idea what was going to happen the following day. Like tomorrow's team project selection day, anything could happen. And it was kind of an incredible experiment. We went through GSP10, and then in GSP11, I kind of peeled off a bit to take some time with family, and ended up living in LA next door to Peter by accident. You want karmic mischief? I will give you that. Ended up writing a book called Exponential Organizations, which some of you may have heard of, on how do you scale organizations as fast as we can scale technology. The book's taken off in a very big way. It looks like it's going to crack into the top 10 best-selling business books ever list with the second edition, which is coming out in a few months. Peter is co-authoring that with me. I'm now on his board at XPRIZE. And what I've been focused on the last few years is coming out of Singularity, because I led all the programs for about 7 years. I made an observation that we have about 20 Gutenberg moments hitting us at the same time. All of the constructs that Ray identified, the intersections of those, just blockchain changes the world completely, or solar energy. And I think we have a full 20. And that's the best kind of summary description I have. My second observation was that it breaks every institution by which we run the world. Third, our current leaders can't navigate this at all. And finally, most of the action is happening at a very local level. And so what we've set about doing is creating a tool set to solve what I call the immune system problem. Jeff, CTO at Autodesk, at the time, Jeff gave me this insight the first time. When you try anything disruptive, the antibodies attack you. And it's bad in big companies, but in the public sector, we have bankers fighting Bitcoin, taxis fighting Uber. And so we've spent all of our time solving that problem. And we've actually cracked it. We came up with a 10-week program that we run inside big companies, piloted with Procter & Gamble, that hacks culture at scale and breaks that immune system problem. And we've done it 60 times with Black & Decker, HP, Visa. We have a nonprofit in Miami, which is where I now live, that runs the same process for public sector, because now you have to hack regulatory policy much harder. It takes 16 weeks, but it works. And we run it half a dozen times. Most notably with the mayor of Miami 5 years ago. A lot of the buzz you hear about Miami is partly our fault. Lily blames me for the real estate prices because we laid the vocabulary down for the thinking these days. What we've been building is basically a decentralized McKinsey's based on this model and this tool set, our community of consultants is now 17,000 consultants in 130 countries, and we give them these tools to transform their companies or their governments. I did a workshop at the Vatican, helping them think about disruptive ideas, because the Pope has the worst immune system in the world, so they called. And probably the strangest thing that's happened for me is about 3 years ago, a political consulting group approached me and said, we'd like to partner with you. And I said, how? And they've been using EXO, the book, to advise heads of state. And when I looked into it, it turned out to be 36 of them, which sounds insane. I spent the early part of 2019 visiting 7 of them. Turns out to be true. And I realized, wow, we can hack the world now, because now we have a community, we have a tool set, we have some credibility, and now we have access. And so we've crafted a plan, which we're actually starting to announce on Tuesday in Miami. We're going to be announcing a community of 1,000 super citizens, and roll that out to most of the cities around the world, a new model for civics, driven by some of the young, future-focused folks, a combination of, say, the SU, Davos Young Global Leader, TEDx, EXO communities, into one group, and let them vote what problems they want to see solved. And so that's essentially where we're heading. The company is heading towards, we're likely to break unicorn status this year on this decentralized consulting model, because we do all of the consulting in the community, and we've learned how to scale a consulting company without hiring any consultants. It's all done in the community. So VJ is a key part of our community, along with some of you others. And it's been quite a ride. So that's what I'm up to. Really great to see all of you. We should do this again, where we can do a formal 5 minutes of what each person is doing, so that we get a good, rich sense of this. This has been great.
Thank you, Salim.
I think Jeffrey's next.
Sure. Can you all hear me?
Yes, sir.
Awesome. It's great to see all of you again. It's been far too long. I'll keep my presentation quite short. I've been did a deep dive into artificial intelligence, and I hit up a company called OneCup.ai, and we did Face ID for animals. There are 7 billion animals on the planet that are in livestock, and we do cats and dogs and even wildlife. We use computer vision to track everything animals that do, and we track them individually by how they look. Combined with Starlink, we're rolling this out worldwide, and we track everything from cattle, calving, all the way up to estrus, you name it. And we basically become the eyes of the rancher on the ground, and combined with Starlink, which is taking broadband to the rural market, to the ag-tech industry, we are fitting a very important void that it remains unfulfilled today. We expect that we will save several million animals between birth and calving, or birth and weaning alone. And I'm very proud of our project. My team is currently 20 engineers, and we are moving quickly. Thank you.
Thank you, Jeffrey. If anyone else would like to speak, David.
Ray, everybody, thank you for being here. I'm not closing this down or anything, but I personally have to take off. Greg, Rick, and Aaron are going to stick around. But before I take off, Ray, I just wanted to say personally, thank you for being a sort of a huge influence on me personally. Like 12, 13 years ago, when I was starting my first startup that was called Metaversatility at the time, I was on my way to Singapore, and I had this book. I don't know if you can see it, but I had The Singularity is Near, and it's just like riddled with my entire, long haul flight to Singapore's just like notes upon notes. And I had printed out my the thing at the time that was the Metaverse Roadmap, which was a consortium of collaborating organizations that were trying to sort of forge a path forward for defining what the metaverse was. So, my career and my creative process has been heavily influenced by the stuff that I read in that book so many years ago. So thank you for being here. It's an honor to have you. And I'll pass the mic back to Greg and to Rick and everybody.
Well, thank you. I look forward to seeing your notes on my next book.
They'll be copious. Yeah. Thanks.